So in this video, we're going to talk about how to add and subtract rational expressions with unlike denominators. So you remember how to add fractions with unlike denominators? Remember, you have to have a like denominator in order to add two fractions. So when you have unlike denominators, you have to first figure out the LCD, which is the least common denominator. Then you're going to multiply one or both fractions by a factor in the numerator and denominator in order to obtain the like denominator. And then once you have like denominators, you can add or subtract. Remember, the LCD is going to be the LCM of the two denominators, right? The LCM is the least common multiple. So for example, if we want to add these two fractions, we're going to look at the LCM of 5 and 15, which is in fact 15. So to obtain 15, I need to take that first fraction and I'm going to multiply the denominator by 3, but that means I need to also multiply the numerator by 3 because 3 over 3 is just 1. And so if I multiply by 1, I'm not changing the meaning of the original problem. So then I'm going to add it to 11 over 15. So this gives me 3 times 2, which is 6. So we have 6 over 15 plus 11 over 15. And that equals 17 over 15. So if we have to subtract fractions, it's the same idea. We need like denominators in order to subtract. So let's find the LCM of 6 and 18. And so that is equal to 18. So once again, I'm going to take that first fraction and I'm going to multiply by 3 over 3. And I'm going to subtract 5 over 18. So that gives me 57 over 18 minus 5 over 18, which equals 52 over 18. I can simplify this. Both of these numbers will reduce by 2. So that gives me 26 over 9. So we're going to extend this idea to rational expressions when we're adding and subtracting rational expressions with unlike denominators. So you're going to start off by factoring the denominator of both expressions, and then you're going to determine what factor is needed for one or both fractions in order to obtain a common denominator. Then you'll multiply the numerator and denominator of each expression by a fraction that equals 1 to obtain like denominators. And then once the fractions have the same denominator, add or subtract the numerators and keep the denominator the same. So what if we're adding 2 over 5x and x plus 2 over x squared? So we're going to start off by factoring both denominators. So we have 2 over 5 times x plus 2 over x times x. So we're going to find the least common denominator, and what we're going to do is we're going to list out all the factors in the denominator and then just not repeat any factors, okay? So for the first denominator, we get 5 and x. So in the second denominator, we have another factor of x, so we're not going to repeat it, but then we have 1 extra x, right? So we're going to add just in 1x, okay? So we don't have 3 x's because one of those x's is repeated, so don't ever write a repeated factor twice. Then you'll end up with a lot of unnecessary terms and factors in your expression. So 5 times x is 5x squared. So in order to get 5x squared in that first denominator, I'm going to take that first fraction, that 2 over 5x, and I'm going to multiply it by x over x. So when I do that, that first fraction becomes 2x over 5x squared. Now let's work on the second fraction. So in order to get 5x squared in the denominator, I need to multiply by 5 over 5. And so that is 5 over 5 times x plus 2 over x squared. And so when I multiply by 5, I get 5 times x plus 2 over 5x squared. So now I have like denominators, so I can go ahead and combine my fractions. So I have 2x plus 5 times x plus 2 over 5x squared. And I'm going to go ahead and distribute that 5. So that gives me 2x plus 5x plus 10 over 5x squared. And so now I can simplify this by combining my like terms. 2x and 5x are like terms, so I can combine them to get 7x plus 10 over 5x squared. Now if I could factor the numerator, I would do that, but it does not factor, so I'm just going to leave this problem as is. Now let's subtract x over x plus 2 minus 1 over x minus 2. So neither of these denominators can be factored. Okay, so what I'm going to do is I'm just going to take one factor from each denominator because there are no repeated factors. So I'm just going to do x plus 2 times x minus 2, and that is my least common denominator. So obtain that least common denominator on the left fraction, I need to multiply by x minus 2 over x minus 2. And so when I do that, I get x times x minus 2 over x minus 2 times x plus 2. So I'm going to go ahead and distribute that x. So I have x squared minus 2x over x minus 2 times x plus 2. Now let's work on the second fraction. So to get the common denominator, I need to multiply by x plus 2 over x plus 2. And that is multiplying 1 over x minus 2. So that gives me 1 times x plus 2 over x plus 2 times x minus 2. And so that gives me just x plus 2 over x plus 2 times x minus 2. So now that I have like denominators, I can go ahead and combine these two numerators together. So I have x squared minus 2x minus, and then that x plus 2 is going to go in parentheses because I'm subtracting all of that. So I have x minus 2 times x plus 2. I'm going to rewrite this subtraction as adding the opposite. So I have x squared minus 2x plus negative 1 times x plus 2. And that is over our common denominator. So let's go ahead and distribute that negative 1. So we have now x squared minus 2x minus x and then minus 2 over x minus 2 times x plus 2. So let's go ahead and combine the like terms. So these two like terms in the middle are going to combine. So we have x squared minus 3x minus 2 over x minus 2 times x plus 2. So now we want to check if we can factor the numerator. So I have x squared minus 3x minus 2. So I need two factors of negative 2 that add up to negative 3, but the only factors of negative 2 I have are 1 and negative 2. Since this is a negative number, they need to have opposite sign, and since 3 is negative, I make the bigger factor negative. But you can see that they add up to negative 1. So this cannot be factored, so we can just like leave our answer as it is. Okay, if you can't factor, just leave what you have, and that is your final answer. So now let's try adding these two rational expressions together. So the nice thing here is that these are already factored. So what we're going to do is we're going to list out all the factors and then not repeat any common factors. So the LCD is going to be x plus 1, and then we don't need to write it twice because it's in both denominators. And then we have x minus 3. So in order to get the first fraction to have that LCD, we need to multiply by x minus 3 over x minus 3. And so that becomes x times x minus 3 over x minus 3 times x plus 1. And we're going to distribute that x. So we have x squared minus 3x over x minus 3 times x plus 1. So now we have our second fraction. The nice thing is it already has the common denominator, so we can just go ahead and combine it. We don't need to multiply by anything, so we can just go ahead and combine it with this expression. And when we do that, we're going to combine the numerators. So we have x squared minus 3x plus 5x plus 1 over x minus 3 times x plus 1. And so we're going to combine the like terms that we have. Notice that minus 3x and plus 5x are like terms. So that gives us x squared plus 2x plus 1 over x minus 3 times x plus 1. So let's go ahead and try factoring that x squared plus 2x plus 1. So when we do that, we have x squared plus 2x plus 1. So we need two factors of 1 that add up to 2. Since 1 is positive, we're going to do two positive factors since 2 is already positive. The only factors are 1 and 1, which does work. 1 plus 1 is 2. So that gives us x plus 1 times x plus 1. So I'm going to rewrite this that we have in factored form. So we have x plus 1 times x plus 1 over x minus 3 times x plus 1. And one of these x plus 1s will cancel. So our final answer will be x plus 1 over x minus 3. So that is the fully simplified form of our answer to that addition problem. So now let's subtract these two rational expressions. So we're always going to start off by factoring both denominators. So we have x squared plus 3x plus 2. So we need two factors of 2 that are going to add up to 3. Since 2 is positive and 3 is positive, we're going to have two positive factors. So we have 1 and 2, which does add up to 3. So our factors are x plus 1 and x plus 2. Now let's factor x squared minus 4, which we can do because it's a special pattern, right? It's x squared minus 2 squared. So that's going to be x plus 2 times x minus 2. So if we rewrite this problem in factored form, we have x over x plus 1 times x plus 2 minus 9 over x plus 2 times x minus 2. So the least common denominator is going to contain all of these factors, but no repeating common factors. So we have x plus 1 and then x plus 2 from this first fraction. X plus 2 I don't need to write again, and then I have an x minus 2. So that's the least common denominator. So to obtain that on the first fraction, I need to multiply by the missing factor, right? So I'm going to multiply by x minus 2 over x minus 2. And so we have that over x plus 1, x plus 2. And so that gives us x times x minus 2 over x minus 2 times x plus 1 times x plus 2. So we're going to go ahead and distribute that x. So we have now x squared minus 2x over, and then all our common denominator factors. So we have x minus 1 times x plus 1 times x plus 2. Now let's work on the second fraction. So to get the common denominator, where the missing factor is going to be x plus 1. So we are going to multiply by x plus 1 over x plus 1. So when we do that, this is what our second term looks like. And so that gives us 9 times x plus 1 over x plus 1 times x plus 2 times x minus 2. So let's go ahead and distribute that 9. So we have minus 9x plus 9 over the common denominator, x plus 1 times x plus 2 times x minus 2. So now that we finally have a common denominator, we can go ahead and subtract these two numerators. So we have x squared minus 2x minus, and then 9x plus 9, right? We're subtracting all of it, so it goes in parentheses. And then that, once again, is over the common denominator. Now let's rewrite this subtraction as adding the opposite. So I have x squared minus 2x plus negative 1 times 9x plus 9. I'm going to distribute that negative 1. So that gives me x squared minus 2x minus 9x minus 9 over our common denominator. And the final step here is going to be to combine any like terms. Notice that I have that minus 2x and minus 9x that are my like terms. So when I combine them, I get x squared minus 11x minus 9 over x plus 1 times x plus 2 times x minus 2. I want to double check and make sure that I can't factor the numerator. So I need two factors of negative 9 that add up to negative 11. Since 9 is negative, I'm going to go ahead and make the bigger factor negative. And you can see I have 1 and negative 9. And then I have 3 and negative 3. None of these factors will add up to negative 11. So I'm just going to leave this as is. The numerator cannot be factored. So now you can go ahead and pause the video and try this example on your own. So when you do this, you're going to fully factor both denominators. So that will give you 5 over x minus 5 times x plus 1. And then the other one will be negative 3 over x minus 5 times x minus 2. So the least common denominator will be x minus 5 times x plus 1 times x minus 2. You're going to multiply the first fraction by x minus 2 over x minus 2, and then the second by x plus 1 over x plus 1. And so when you do that, you will combine these like terms. You have 5x minus 10 minus 3x minus 3. The 5x minus 3x will combine, and that gives you 2x, and then the minus 10 minus 3 combines to give you negative 13. The numerator cannot be factored, so you're just going to leave this answer as it is. So remember, to add or subtract rational expressions with unlike denominators, you're going to factor the denominator of both expressions. Then determine what factor is needed for one or both fractions to obtain a common denominator. Multiply the numerator and denominator of each expression by a fraction that equals 1 to obtain like denominators. Once the fractions have the same denominator, go ahead and add or subtract the numerators and keep the denominator the same.